Hey guys, in today's video we're going to be looking at Lewis symbols. We are going to, at the end of this, be able to recall what valence electrons are. We'll be able to summarize the differences between core and valence electrons and use them in order to determine our Lewis symbols for atoms and ions. And we should be able to, for any main group element, determine how many valence electrons we have or ion. We're going to start this out by talking about our different types of chemical bonds. Our first one that we're going to look at is an ionic bond. So an ionic bond is an electrostatic interaction between charged particles. And here we're talking about full charges. So this is a fairly strong attraction. And the attraction, that electrostatic attraction itself, is the bond. Then we have covalent bonds. And our covalent bonds are when we share electrons in pairs between two atoms. And this can be one or more. Generally, we consider it between 1 and 3 pairs. And then that pair of electrons that's shared, or pairs of electrons that are shared, is a bond. So each individual pair of electrons that's shared is its own individual bond. And then we have metallic bonds. And this is one we haven't really talked about, and we won't really visit until Chem 2. But it's the idea of we have metal atoms sharing their valence electrons. So atoms, not ions here. And all the valence electrons are shared between all of the atoms. We consider this to be a sea of electrons, a delocalized sea of electrons, where our metal cations themselves are in it, and then their valence electrons are the sea, but it still charge balances to where we're not really thinking about it in terms of ions. So we have a sea of electrons with metal cations arranged in an organized pattern. Again, we consider these to be just regular atoms, right? They're not ions, but the valence electrons are delocalized, so they're not staying on one of the metal atoms. So we kind of consider it a bunch of cations with the electrons delocalized around them, like so. Okay. So we can use Lewis symbols to show these valence electrons that a atom or ion has. So a Lewis symbol is a method of denoting potential bonding electrons by using dots to represent valence electrons. So in the case of ionic compounds or covalent compounds, we can use these symbols to see what type of bonds are going to be formed. Okay, and within our Lewis symbol, our valence electrons are going to be placed in one of 4 quadrants around the element symbol. With our Lewis symbols, this can be done for atoms or ions. And it's called a Lewis symbol because it was developed by Gilbert Lewis. So the Lewis symbols, as I said, can be a really good way of kind of showing how we can make bonds within a compound or molecule. And some things to kind of note that if we have atoms, they're going to form compounds one of two ways. So either by sharing electrons, so covalent, or by the give and take of electrons. Which is going to be our ionic species, right? And if we have ionic species, remember our metals are going to lose electrons and our nonmetals are going to gain electrons. So metals will lose electrons and nonmetals will gain electrons. And by looking at our Lewis symbols, we can kind of predict that. So real quick, let's look back up here on this. So we can see we go from group 1A to group 8A. And on more modern periodic tables, this is going to be 13, 14, 15, 16, 17, and 18. This is just shown as kind of an older way of representing those group numbers. So we have groups 1, 2, 13 through 18, and these are our main group elements. So those include our main group elements, and we can see going from 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8 valence electrons in our Lewis symbol as we go from group 1A to 2A to 13 to 14 to 15 to 16 to 17 to 18. So we can kind of equate our number of valence electrons to what group it is in. And as you can see with the Lewis symbols, we're putting our electrons in one of 4 quadrants around our elemental symbol. And we put them in singly first before pairing them up. And then from this, again, we can kind of predict what type of species we're going to form, what type of bonds we're going to form. If we look at our Lewis symbols, for instance, lithium is going to form ionic species. And if we combine it with something like fluorine, lithium would give up that 1 electron, fluorine would take that 1 electron, so that each of them will have either a completely filled or a completely empty 8 electrons around it. We can also see that neon already has 8 electrons around it, so it is happy and doesn't want to do anything. Okay, but yeah, these are very helpful for determining what type of structures will form. The steps for drawing a Lewis symbol is very easy. We're going to count the valence electrons around the atom or ion. Then we're going to place those valence electrons around the elemental symbol, singly first. Then we will pair them up. And then if we have an ion, we're going to add brackets and include the charge right outside top right. What we're basically trying to do with each of these is get to a point where we have an octet. So when we looked here, something like we would see with neon, where we have 8 electrons around that atom. So every atom, for the most part, wants 8 electrons around it. The octet rule basically says that atoms are going to be the most stable when their outer shell is filled with valence electrons. And generally when we're talking about this, the things that obey what we call our octet rule, we're thinking about things that are main group elements. So our 1, 2, 13, 14, 15, 16, 17, and 18. So all of them want to achieve a noble gas electron configuration. So having those 8 electrons around that central point. 8 valence electrons. 8 valence electrons. Okay? So this can be achieved by taking in electrons, giving up electrons, or sharing electrons. But with our Lewis symbols, we're really just going to look at giving up or taking initially. And then when we get into our Lewis structures, we'll actually look at sharing those electrons. So right now we're just looking at our valence electrons around an atom or a monoatomic ion. Okay, there are a couple of exceptions. Hydrogen and helium. And then lithium and boron don't usually want an octet. Okay, they're all going to be our lighter elements, and they can have a little bit fewer electrons and still be stable. As a note also, with our main group elements, the reason that we're talking about 8 valence electrons is because we want to fill the S and P subshells. To fill an S subshell, you need 2 valence electrons. To fill a P subshell, you need 6 valence electrons. Add those together, that gives you your 8 valence electrons. Okay, so let's try it out. We want to draw the Lewis symbols for calcium, oxygen, and calcium oxide. So calcium and oxygen. Calcium itself is going to have a total of 2 valence electrons. And we know this because it is in group 2. And then oxygen is in group 16, so it has 6 valence electrons. So we're going to fit electrons around our atom. So calcium, like so, and then 1, 2, 3, 4, 5, 6. There's our 6 electrons right there. Calcium oxide is going to be an ionic compound. So it's going to be formed from 2 ions. Calcium 2 plus and oxygen 2 minus. So calcium 2 plus, to go from calcium to calcium 2 plus, we're going to remove these 2 electrons. And then to go from our oxygen to oxygen 2 minus, we're going to add electrons in. And what we get is calcium 2 plus and oxygen 2 minus. like so. So this would be our Lewis symbols for either our atoms or ions. And that is everything. Well, we'll talk to you guys in the next one.